84. Shaded region. We have to find the area of the shaded region. Okay, this is the function that they give us. The area goes from -7 to 7. Okay. Equal to 2. What is the area of the region? All right. So it's just two functions. The tricky part here is you can't do top minus bottom. Well, like, you can do top minus bottom. So what I would do is just the old-fashioned geometry, right? This is a rectangle out of which we're subtracting this little half an ellipse, it looks like, kind of. So this rectangle is a it's a 14 by 2 rectangle. So the rectangle's area is 28, 14 times 2. From that, I am subtracting this area, which is the integral of this function cosine pi x over 10. And now the limits of it is what I have to, like, what is that value? That's what you need to know. So you can use your calculator, I guess. I'm trying to think if that would be if that's the easiest. It's probably the easiest. I mean, you know that, maybe not. If you're familiar with the cosine graph, which, my goodness, by now you should be, just a regular cosine graph is 0 at pi over 2. Cosine of pi over 2 is 0. So to make this pi over 2, x would have to be 5. And because of the symmetry, this would be -5. It's an even function. So yeah, I think that's the easiest. But you could also graph it and find, I don't think you're going to be able to find the roots, though. You'll see what I mean when you try it. So I would find this area from 0 to 5 and double it. So, oops. Okay, let's clear this. So I have 14 times 2 here, that's 28. 20. It's not this gonna work out. Okay, so 28 minus. Oh, I forgot to double it. Let me double the integral of square root of cos pi x over 10. Square root of cos pi x over 10. Over 10 is just 0.1. So it's just easier for me to plug it in this way. Close the first parenthesis, close the second parenthesis, comma x, comma 0, comma 5. Let's see what we get. Sometimes this takes a while. Again, my calculator is pretty old. 20.372, which is choice C. And that's that. Okay, this is 14. All right, 85. Let's read it. Okay, so we know that for some function, the line tangent to it is always larger than the function. So all that means is that your graph has to either look like this, where the tangent is above it. The tangent has to be above it because it's larger than, or it has to look like these. These are the only two options. In either of these options, the tangent is larger. The tangent values are larger than the graph functions, the values. So in both cases, the function has to be concave down, which means the second derivative has to be negative. I guess. Yep. Okay. Yep, that would be choice E. Okay. Now number 86. 86 over here. Oh, this is cute. This is very cute. Okay. What's the value of that? So we're going to use integration by parts. So let u equal to x, because you can't take the antiderivative otherwise, okay? dv equals f double prime x dx. So then du equals dx and v equals f prime of x. So by the formula, we get that this is uv, which is x f prime of x, minus the integral of v du, which is f prime of x dx. And this is from 0 to 1, this is from 0 to 1. So if we plug in 1 in here, we get 1 times f prime of 1. Plug in 0, you get 0. Okay, this is simply f of x. So it's f of 1 minus f of 0. Right? Okay, from the table, f prime of 1, this is f prime. F prime of 1 is 6. So that's 6. F of 1 is 2, and f of 0 is 1. So this is 5, which is choice B. Okay. Next, 87. Okay, that's the graph of f prime. What are the following statements about f at x equal to -2? Okay, at that corner, they're trying to trick you. This is a tricky one. F is not continuous. That's not true because the derivative exists. It has to be continuous. The derivative is 3 when x is -2. So A is false. F has an absolute maximum. No, because the derivative doesn't change sign. The derivative has an absolute maximum, but not the function. The derivative of f does not exist at x equal to 2. Yes, it does. It's 3. And D, the graph of f has a point of inflection at x equal to -2. Well, the derivative here, the second derivative, f double prime, or the derivative of f prime, does not exist. And it changes from positive to negative. So yes, choice D is true. 87 is your answer. Okay, 88. At which of the following values of x does f have a local minimum? Okay. So they're giving you the derivative, so you don't have to do anything. So you're looking to see when the derivative changes from negative to positive. So let's see. Okay, so my function is sine of x squared. So let's go sine of x squared. That's the derivative. And which of the following objects does have a local minimum? So I'm looking at the values and they're all around 2, like between 0 and 2. So actually between 0 and 3 about. So I'm going to make my window be between 0 and 3 for x. And I don't know if the y max is good enough. Second trace 0. Let's see what we get. So we're looking for negative change to from negative to positive. Okay. So this is from positive to negative, so I'm not interested in that. Okay, oops. So press enter. That's from negative to positive. That's going to give me a local min. 2.507. Is that one of the choices? 2.507, that's choice A for number 88. Okay. 89. The alternating series test can be used to show convergence for which of the following? Well, you have to recognize that number 1 is not really an alternating series. Its alternating series has to have -1 to the n or n plus 1 or something like that. And this one does not follow the definition of it, so it can't be that one. This one is the alternating harmonic, and you can use the alternating series test because 1 over n decreases to 0, so it converges by the alternating harmonic series. This one you can't, because the limit of this is not 0. It decreases, but it doesn't go to 0. So it's only 2 can be shown, so it's choice B. Okay. 90, almost done. The function blah 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 and its derivative. Oh, how nice, they gave you the derivative. Oh, mean value theorem. So that's just that's f of b minus f of a, slope of the secant. There has to be a point where the derivative is equal to the slope of the secant. So then you just substitute. Okay. So this one is a calculated question, because if you see the answers are decimals, then you know that's a calculated question. So what I would do is I would, okay, let's, the function is 3x minus 4 cosine 2x plus 1. 3x minus 4 cosine 2x plus 1. Okay. Okay. Then I'm going to put the derivative here. So math 8, y1, comma x, comma x. And this left side of the equation, f of b minus f of a over b minus a, our a and b are negative 1 and 2. So I could plug in directly into here to have the calculator figure it out. Okay, so my f is in y1. So let's use that. Oh, wait, I should have put this in parentheses. Okay, so that's 2, f of 2 minus f of 1, negative 1, sorry. Close that parenthesis and divide that by b minus a, which is 3. Okay, so that's the left side of the equation. The y1, I'm not interested in graphing. I just need it there for the derivative. Though I guess I could have, they gave me the derivative, so I could have just plugged it in without putting, oh no, I needed y1 for y3. So anyway, so I'm going to, so basically what I did was I put the left side of the equation in y3 and the right side of the equation in y2. And I'm going to look for the intersection points. Okay. I just have to make sure, though, that my x value is between negative 1 and 2. Otherwise, I'm not going to get all the intersection points. So let's go back to our window. It's because we have the window from before. So negative 1. Let's make the, so you want the x min negative 1. And you want the x max to be 2. And the y, I don't think we care. Second trace intersect. Let's see. Looks like there are 2 intersection points because the graph is coming. Okay. Boy, it's slow. So just by looking at these numbers, this first intersection point, let's look at the choices. Looks like it's negative something. Maybe choice A or choice B. It's got to be choice A or choice B because there are two intersection points, and one of them is negative. So let's just, I don't even know where my cursor is. There we go. Okay. Just press enter 3 times and you should get it. And you don't care about the other one because once you find one, you know what the choice is. Negative 0.479. Negative point, so that would have to be choice B. Okay. Okay. Is that 91? Oof, 2 more. They give you the volume. Okay. How fast is the water level rising? The height of the water is 5 feet. So you see how the radius is a third of the height? So that's the relationship. So radius is a third of the height. So this becomes pi over 27h cubed. So dv dt is going to be pi over 9h squared dh dt. And that's what I'm looking for when the height of the water is 5. So, and 6 cubic feet per minute. So that's dv dt. And so 6 times, this is 25 pi over 9. So we do this and we put this in the calculator. And if we do this right, the answer to 91 should be B. Okay. I'm just doing this quickly because I'm running out of... Okay, 92.